Hi again, let's talk about this next example. This is question 6. An amateur golfer hits a ball up into the air. The path of the ball follows the relationship h equals minus d squared plus 20d. Now, the fact it's minus d squared means it's going to look like this. All right? So just so we know, that's going to minus d squared does that. It's got to do that. Where h is the height of the ball for a horizontal distance d from where the ball was hit. So h is this way, and d is that way. That's what it's going to be. Both h and d are in meters. Okay, that's good. Using graphic technology or a table of values to draw the graph of this relationship from when the ball was hit to when it landed. Okay, I'm going to use, as they suggest, graphing technology. You can use a table of values to practice, but here's one I prepared earlier. There's no option to use d and h, so I've used x and y. Now, if you have the default on the tablet, you can sort of pinch the axes to expand and contract the axes. So you can do that. But another option is you can go up to the spanner in the corner and you can set different values for your x and y values. So you just need to fiddle around a bit and go a bit bigger and then zoom in and out. But that's what we want to do here. So you notice that it goes from 0 to 20, goes up and then comes back down again. It seems that the maximum is 100. So my y in this case is h, actually, my x is d, and goes along to 20. So I'm going to take a screenshot of this and plug it over to the other side. So we'll just trim it a little bit so that we get rid of all the unnecessary stuff. You can just sort of have it from that, and we'll just copy it, and we can go across and put it over here, which would be nice. Insert. Let's see if we can just paste that in. There we go. Okay, so we'll just move that. And so that is h equals minus d squared plus 20d. All right, and so that is my h, and that is my d, is what that means. Okay, now what is the maximum height of the golf ball? Well, what was the maximum height of the golf ball? Well, the maximum height is here at the vertex. The vertex is the maximum height. And what's the kind of coordinates of that? Well, it's 10 horizontal, 100. All right, 10, 100. So if we do that, the maximum height, this is part B, the maximum height is 100 meters. And they hit that really high. Kind of hit it high up in the air. It's doing pretty well. How far from the golfer did the ball land? Now, what this model doesn't show is bounces. It may very well, the ball might actually go like this. If I did it in blue, it might go wee up along and down like this. And then, of course, it might bounce, 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 bounce. But it doesn't show that. It only shows the initial trajectory. So we just worry about that. And so the point where it lands, of course, is here. It starts on the ground, it goes all the way up to the air, hits 100 meters, keeps going, and then comes down to 20. So C lands 20 meters away from the golfer. Now, to me, that's not a very good shot, but that is certainly what the maths in this case is telling us. All right, so understand what the interpreting thing is. Maximum is where it kind of goes up to. The distance, in this case, is the horizontal distance. And so this is literally how it flies through the air, height versus distance over time. And parabolas are, in fact, what's used to model flying through the air. Things that fly through the air, like you throw a football or you kick a football or whatever it is going to go through the air in a shape of a parabola. So there we have it. Okay, so let me try the next example in the next little video.